Hello, everybody. Okay, so it has been a long day, right? So today is going to be a little more like a story on a real use case that we did like 3 years ago, even before the HAI existed as such, right? So it started with, here it is, with a company. But before getting in there, is that who is Barbara? No, probably you will be all wondering, what is this company with this funny name? So it's not somebody, that's not the founder. It's long story short, is because we started a company based on the cybersecurity, and there's an old saying in Spain that you only remember Saint Barbara when it's an issue, right? So you only remember cybersecurity when there's a problem. And after that, so we've been evolving the company because of the customer's request, and we have evolved it into what it is HAI. And what we do now is that we are able to deploy we are an edge management platform that allows to deploy AI models across many different thousands or hundreds of different devices in a very cyber secure way, and also includes a lot of infrastructure around it for the industrial environment. So you have an ecosystem of applications that allow to create these use cases that are important. So as I was saying, it all started with this use case about HAI and a journey into that with a customer. It's a big customer in Spain called Acciona. You may not know, it's a company that covers energy, construction, and other things, and also water. So they created in 2019 a digitalization department whose idea was to bring innovation into the water, right? So they cover the whole water cycle, but in this case, but they have an issue in a particular use case, what is the desalination plants. So the desalination plant is a funny thing. It looks like, okay, the water is everywhere, so it should be quite easy. You just remove the salt and that's it. And basically that's what we do. So they get the water, first they pre-treat it, they take all the organics out. They go through a process which is called reverse osmosis, and they take all the salt out, but there's still other products other chemical products into the desalination process. And what they do is they treat it afterwards with some chemicals, right? What is difficult to get rid of is boron. Okay, so the boron, okay, there's a way of treating it. You put caustic soda on it, and then you treat it. But you need to know how much boron there's on the water. Otherwise, you may have issues. It may be bad for the health, or even you can get penalties. So they say, okay, let's analyze it. But when they analyze it on the lab, it takes normally 12 hours, 24 hours in order to know exactly what is the amount. And when that happens, they cannot treat it because the water is already gone. So they have to find a way of improving it, right? So they say, okay, how can we estimate the amount of boron that's in the water so we can treat it more precisely? And even better, can we predict how much boron are we going to use? And there's another thing that they also thought about doing is energy optimization, because there's a huge amount of energy they need to put into getting that. But that's going to be the second stage. So originally, say, okay, they had this idea, no? They had this vision. Say, we're going to create a virtual sensor for boron. That's quite simple, right? It doesn't look like a very complex model anyway. But still, they had to do it, and they say, okay, they get all the things that are already, the pH, turbidity, or temperature, all that. So they get all the data. They got the results from the lab. And say, we should be quite straightforward. But they also thought, okay, we're going to do it. We're going to deploy to all the 1989 plants that we have in the world. But there's an issue here because the plants needs to be, it's a critical infrastructure, so the data cannot live there. And they cannot leave the premises, they cannot leave the plant. Okay, so well, let's see how we're going to do it. So they say, okay, we'll figure that out later, but that's our vision, that's what we want to achieve. So they started, and they found other challenges as well. That even that they had the data is difficult to get, because in the lab, one of the main issues is that, okay, they maybe do one measure per day or twice. So in order to have enough data, you can imagine how much years you need to get of data to that. Also, the quality of the data, no? Because there goes the guys to the lab, get the sample, they put it in the lab, they write in an Excel sheet the time. So that was it was done until. So it was also an issue. They have to clean a lot of data before that. Also a problem with cybersecurity. There are plants where you cannot connect, you cannot get the data outside of the plant. Actually, to get all the data, they have to ship the data in a hard disk in a special place to the laboratory to do everything. Another issue is that there's a lot of variability because of the business. They do not have the same plant everywhere. It's difficult. It's different, each one of them, because they have concessions, one have been built by somebody else, not from them, one have some system, other have other ones. So that's difficult. So they were all the challenges that they say, but they say, okay, we'll figure it out later. First of all, let's try to build the model. So that's what they did. Okay, that's going to be quite straightforward. So they went to the lab, and they just installed a computer, and they create the model. They had to clean up the data and all that. They took them quite a long time, but they managed to do it. They clean it. They create the model. They say, okay, now I need to connect to the SCADA system. So, okay, I need to find a way of connecting it. So it was a pain to say, well, but they finished. They did it, okay. Now let's deploy. We have this model. It's working here. Actually, we tested. It works very well, the model. Let's deploy it somewhere else. And that was impossible. They say, we need to find a way to do that. So they call us. No? They call Barbara. And the advantage is that they knew us for some reasons. So we managed to sort out different type of problems that they had to deploy these models. These were not the problems or creating the model itself originally or having the model. It were other type of issues, no? And here, what we solved for them is that we have a central platform that allows you to manage all the different equipment that they have across the different plants. So they sort already something that is going to be easy to deploy. We are based on Docker, so that's another advantage because say, okay, it's going to be quite standard to deploy everywhere, so I don't need to take care of everything. It's a secure orchestration. We take care of the operating system. We take care of the cybersecurity. So we also take care of upgrading of the model and all of that. We have all the connectors to connect to the different systems, and for them already also sort that part out because it's getting the real data is complicated. And then at the time we didn't have it, but now we do, but basically we were able to deploy the MLOps there. So more or less this is our platform here. You see from a central panel, you see all the different devices that are installed across the wall. You can go inside of them, and you can deploy the application in a single click, okay? You can deploy a model in a single click. And also, we have a marketplace full of applications that allows you to do that, all the necessity connections, everything that is around, getting the data, exploiting it, and in an industrial environment. Because the industrial environments are quite specific. So they have their complications. So we have that part, so that we sort it. And what we do, so the way we propose a solution, it's something like this, okay? As I said before, we are just an orchestration platform. So we don't actually see the data. That's important for cybersecurity. All the data stays on the plants. The only thing that is on the cloud is the orchestration. So we only see that there are things and there are applications that are installed. So you hear everything here is installed in an edge device. These are bigger edge devices than all these microcontrollers you're talking about. So some of them were from Advantech, another from Schneider. So we create that part. So they put this device here, and then you can deploy the models, or your own Docker applications. You can deploy straight away the models, and a lot of other applications that you can deploy, even someone from also IE, like YOLO, Yama, all that you can deploy straight away in a single click to all the devices. And thanks to this type of architecture, and because of the flexibility of the platform, allows them to create different type of use cases. So they say, okay, how are we going to do it? They have 3 different type of models to deploy. originally it was thought to do like a centralized training, so because they already have the model centralized, so we're going to deploy all the plans. That was the first idea. But then they realized that they have an issue. Every single plan was different. So the membrane is different, the sensors are different, so the model that they have in the cloud doesn't work. They need to have a different model on every plant and a different model for every rack, kind of different one. Okay, so one idea was, okay, let's do it centralized, a different model, then they have to create 180 times 10, so 900 different models in the cloud. That was a pain. So, okay, we can do something different. Why can't we do it local? And that's what we propose. So we propose a solution that allow them to deploy locally and to train the models locally. I get there. And also, there's another option of being federated, but although we haven't done it, but basically similar, no? You train the centralized, you send it to the on-premises, do the inference, then you send the data back to the cloud, and you retrain the model that you send over there. But it was not the case. For them, it was more a local training. So in order to do that, we do this type of architecture that is quite standard. This is not only for them, I will go to them later, but basically it's here. Normally we have always this type of architectures that make it very flexible to deploy the models on them. So we put a local MQTT broker. This is an edge node, right? Everything is in the plan, on one of the racks. You put an MQTT broker there. From there you create the connectors. Here is one, but you can have any type of connectors. So all the data is standard there. And then from there, you connect the model. So the advantage is you have a single place where all the data is concentrated. And from here, you can send it also then to another database. You can send it to the cloud. This is not for them, but this is more like a generic. You have an ML monitoring tool that we also see, so you can see whether you are discontinuing. So this is the applications that normally at Barbara, the way we deploy normally these models, or how we make them available for everybody, it's this type of architecture. And that's very flexible because they allow to deploy different models in the same device. So let me go. So what did we do for them? There was a little swap here. So finally, what they started is that the sensor, the MQTT broker, TensorFlow, we have an Influx database for time series locally, and a Grafana, it's also to see everything that's happening on the model. And then for the local training, that's the one that we were talking before. We put also a Jupyter Lab here, a notepad with a Python model that they had it, and an ML flow that allows them to have different versions of the model. Then they can compare it with the real data at the end of the day, and then they can switch and select the best one. So we are doing for them a local training locally for every one of the racks on every one of the plants. And that allows them to create a specific model for them. So that's another interesting use cases for HAI. It's not only reducing data to the cloud. It's not only lowering costs. It's because you can do it specifically at a different model per each device because the environment is different everywhere. So what they manage is that, what I mentioned. They put the model. They have, now they are able to do automated estimation of boron. Now, thanks to that, they are reducing the amount of chemicals they need to use. And also another advantage is that they can manage all these devices in all the plants locally. And now they have like, this is a little bit old now, but they see more or less everything here, all the different things that are reading, and then they can compare with the real one, what is predicted, what is real, so they can be sure. And also, it gives all the people in the plant, the confidence that this AI thing that for them is quite science fiction is real, because okay, actually it's happening, it's doing what it was supposed to do. So that really helps. So how was at the end, the impact? So just per planning 1 year, they saved more than $200,000 in reducing of chemicals and fines. That's important. And fine, and also the health improves. So in 3 years, if you put it everywhere, it's like more than $70 million of savings that you may have, and also help them to go much, much faster to deploy everywhere. So, well, basically that was the idea. So now, because I'm, as said, I'm the VP of sales, so I need to do some selling here. So why Barbara? Actually, we are a great solution because allows the industrial companies to have security that we're gonna have distributed equipment that is secure, and we can manage from a central platform, and we are very focused in the cybersecurity. There's this thing, ISC 62443, a recommendation of cybersecurity that makes that the equipment has everything is encrypted boot, no open ports, all that. So we comply with that part. That's the part with Barbara that we mentioned before. We are edge native solutions. So we are cloud agnostic. You can integrate with any type of cloud. We are hardware agnostic. We can deploy any type of hardware. Normally with any type of microprocessor hardware, no microcontrollers yet. We are tailored for the OT environment, so we have more than 100 OT applications ready. So we can be very flexible, we can integrate with different systems, we can deploy other tools. I didn't mention, but that was the first use case, but now they were putting tools on top of that. They are using our infrastructure also to deploy the traditional OT tools that they do, and for them it was a pain to do that everywhere. So now, from a central point, they can put it everywhere. We are AI focused. Actually, we were doing this like 3 years ago. It's AI before anybody was like, it was a buzzword at the moment. No? We say, okay, we are doing already AI at the edge. And it was interesting because it was driven by the customer needs. It was not something that we thought it was a good idea. And also UX orientation. It's a pity I haven't been able to do a demo because, well, the computer is over there. And they don't allow me to do it. But it will be great if you guys talk to me and we go and do a demo. Even if it's an OT tool, it's very easy to deploy an application, deploy AI models, all that. It's a single click and it's already embedded. So, well, still we have a free trial here. So if anybody wants to access there and connect, we will be gladly do a demo for you, create a trial account so you will be able to access it. So that's it. Thank you.